could be quartets, so depending on what can be given to you. But if you are to determine the differentiation of a particular equation from the first principle, what we do here is, let's consider this example where you have your y to be equals to a function of x. If you are asked to differentiate this from the first principle, all we need to do first is to consider what we have on our left hand side, and that is our y. And what we have on our right hand side, we have our function of x. So since you have a direct relationship between our y and our x, so automatically as your y increases, the same applicable to your function of x. So that means that if you have your y plus a change in x, a change in y rather, so y increases, then the same will happen to the function of x this way. Now, I can decide to say that subtract function of x from both sides. Subtract f of x from both sides. So if I'm subtracting f of x from both sides, so I will have y plus change in x, change in y rather, minus f of x equal to f x plus change in x minus f of x. On this side, you have a consistent scenario, but on the left hand side, you have y and x. So I want to change this my x to y, so that you have a kind of a homogeneous situation. So in that situation, we have, since we know that our y equals to f of x, so we can say y plus change in y minus y is equal to f of x plus change in x minus f of x. Then if you have this y can cancel this, then we have change in y to be equals to f plus f into x plus change in x minus f of x. Then the next thing, divide both sides. Divide both sides by changing x. And whatever you do to the left hand side has to be done to the right side of the equation, to the right hand side. So you have this plus this minus f of x over changing x. Now, it should be noted, or you need to recall, that f of x plus change in x minus f of x over change in x, you take the limit. Taking the limit as change in x tends to 0. Change in x tends to 0, then we have, what that means is that we have f of x plus change in x minus f of x over change in x. You are taking the limit as change in x tends to 0. This one becomes f prime of x. It becomes f prime of x, and this is an important identity in differentiation. It's an important identity in differentiation. So we have a scenario like that here. So we have change in our y over change in x. We take the limit as delta, or change in x tends to 0. Then we have this f of x plus change in x minus f of x over change in x, limit as delta, change in x tends to 0. So on this side, when you have change in y over change in x, taking the limit as change in x tends to 0, then we have dy dx situation. Then here we have, this is an important, so you improve this identity, then you have f prime of our x. So this is what is known as differentiation from the first principle. We can consider some examples to justify our claim. Example 2, y equals to x squared. Let's say A, y equals to x squared, B, y equals to 2x plus 5. we have to differentiate the above using the first principle approach. So I have to differentiate it using the first principle approach. So y equals to x squared. I have to differentiate this using the first principle approach. Then that means we're going to have y plus change in y. Then we'll have x plus change in x all squared. Then we'll have y plus change in y. Then we expand this. If you expand this, we have this on this, x squared. That is how to expand. This times this times this, that's plus 2x change in x. Then this square plus change in x squared. So that is how to expand that. So by expanding this, I have this. Then the next thing to do is to subtract y from both sides. I want to subtract y from both sides. So what am I saying? So I have y plus change in y minus y equals to x squared plus 2x change in x plus change in x squared minus y. So that is what I have done. Then this one can cancel this. So we have change in y here, which is x squared plus 2x change in x plus change in x all squared minus this y. Remember, it is x squared, so I can replace this with x squared. Then I will have this can cancel this. Then I have change in y to be equals to 2x plus 2x change in x plus change in x squared. Then it is evident that change in y equals to 2x plus change in x, because change in x is common, so I factorize change in x out. Then I will divide both sides by change in x. So this I will have change in y over change in x equals to 2x plus change in x over change in x over change in x. This cancels this. Then I have change in y over change in x equals to 2x plus change in x. Then taking the limits, taking the limits as change in x tends to 0, then I'll have change in y over change in x, limit change in x tends to 0 equals to 2x plus change in x. So as you are taking the limit, this one becomes dy dx, remember, which is equal to, and as it's changing to, as this tends to 0, automatically this one becomes 0, 2x plus, it is not as if it is exactly 0, but it approaches 0, so you assume that this is 0, so 2x plus 0 and 2x. So that means from the first principle, dy dx of what you have is 2x. Now, the second one that has to do with y equals to 2x plus 5. We still follow the same approach. So we have y plus change in y. Remember, we are differentiating this from first principle plus 5. Then what we do next is to subtract y from both sides. Then we'll have y plus change in y minus y equals to 2x, 2 into x plus change in x plus 5 minus y This one cancel this, so I have change in y here. Then this one must be homogeneous. You have x as dominant. Then that means we must replace this with what we have here. Then have x plus change in x plus 5 minus. Remember that you have a linear situation here, so it has to be protected with a bracket so as not to alter the result. Then you have change in y equals to, you have 2x plus 2 change in x plus 5. Then this will be 2x minus 5. So this cancel this. This cancel this. Plus 5 minus 5. That's also cancel this. So I have change in y equals to 2 change in x. So divide both sides by change in x. So I have change in y over change in x equals to 2 change in x over change in x. Differentiation of sum and difference. Y equals to ux. So automatically, you are talking about this is sum now. You have to differentiate this. You have dy dx will be equals to d du dx plus dv dx. Then for difference, we have y equals to ux minus vx. So dy dx is equal to du dx minus dv dx. Let's